This is Algebra lesson 6.1. This is graphing systems of equations. Okay, let me explain this really quick. If I have y equals 2x plus 3, that right there, what is this thing again? That's a line, right? That's a line. How many answers are there to this line? There's an infinite number of solutions to this, right? There's an infinite number because it goes forever. Here's the deal. Since it's a line, just very briefly here, I need you to understand this concept. Since it's a line, and it crosses at 3 and has a 2 slope, our line with our straight edge, I don't have a straight edge, but there's my line, right? In other words, give me a solution to this. Give me a solution to this equation. Give me a solution. 0, 3 is a solution. What else? 2, 8 would be a solution. What else? 1, 5 would be a solution. Does that make sense? You're looking at them. There's an infinite number of solutions. Do we all agree with that? It's a line. Okay, so there's not one solution. There's an infinite number of them because it's a line. It can go, there can be whatever x is, there's going to be a y. Whatever y is, there's going to be an x. An infinite number. Now, this is an equation, or this is a line. Here's the deal. When I give you a second one, and I say that this is a system, and I go y equals x minus 2, what this means is there's a second line out there, right? There's a second line. Now, you told me that 0, 3 was a solution, and you also said that 1, 5 was a solution, and that means that 2, 7, I didn't draw it very well, but 2, 7 would be a solution, but whatever, there's an infinite number of solutions. With this one, y equals x minus 2, it crosses here at negative 2, and it's a 1 slope, so it's going to go like this. It's going to eventually go down here like this, and it will eventually hit, oh boy, let me see, where is it going to hit? Right there. It will hit right here. Okay. Here's the deal. These two lines eventually cross at a certain point. They eventually cross at a certain point. I'll put it in red. The two lines cross at a certain point. So then, listen, forget where they cross. How many solutions are there to the second line I drew up there? How many solutions are there to the second line? There's an infinite number of solutions, right? There's an infinite number of solutions to the first line. There's an infinite number of solutions to the second line. But since we're talking about a system, the answer is going to be, where is x and y the same for both? Right? Where is it true for both? So, listen, since all of these, since this and this and this and this, all of these are a solution to the first one, and all of these, here, are a solution to the second one, it's where they cross at that exact point that they will be a solution to both. Do you understand what I'm saying? So what you're going to do is you're going to graph each line individually, and you're going to see where the two meet, and the exact point that they meet is a solution to both of them, which is the only solution to the system of equations. Does that make sense? It's the solution to the system, since it's the only point that it's true for both. The other possibilities are that what if they are both the exact same line? Then how many solutions are there? There's an infinite number. If they both happen to be the same line, then there's an infinite number of solutions. What if the two lines never touch, which would mean that they are parallel? What if they never touch? Then what's the solution? There is no solution. They will never touch, which means that they're never going to be true for both, which means there's no solution. Does that make sense? So that's the options. Is they cross once. Awesome. That's the solution where they cross. They're the same exact line, which means that there's an infinite number of solutions. And if they're never touched, which means they're parallel, that means that there is no solution. Does that make sense? Okay. The only way to do this, people, is to literally, no matter what equations I give to you, is you have to turn them both into what? Slope-intercept form, right? I have to turn them into something to create my line. So no matter what equations I give you, you've got to turn them into slope-intercept form. Once you do that, you can then look at them and say, wow, they're the exact same line. Or you can look at them and go, wow, they have the exact same slope, but cross the y at different places, which means that they are parallel. Or you can look at them and go, okay, different slopes, you know they're going to cross somewhere. Does that make sense? Different slopes means they're going to cross somewhere. That means that we have one solution. So everybody look at page 333. Look at page 333. There's some terminology that you're going to need to know here. There's some terminology you have to know. At the bottom of page 33, there are a few things you got to know. There's a chart down there. Okay, the bottom of page 333, let's read this whole thing where it says the possible number of solutions. The two equations, y equals 4x plus 1500 and y equals 10x, form a system of equations. The ordered pair that is a solution of both equations is the solution of the system. We just said that. A system of two linear equations can have one solution, an infinite number of solutions, or no solution. We just said that too, right? You can either have one, an infinite number, or none. If a system has at least one solution, so this is important, if it has at least one solution, it's considered to be consistent. Now, consistent, A-N-T. What are the two possibilities? If it says there's at least one solution, that means that it's going to be where they cross once, or they're the same line. That means they're consistent. Does that make sense? So look down there at the chart. You see what I'm saying? Look at the chart where it says that there's exactly one solution. That's called consistent and independent. We'll get to the dependent part. And then if there's an infinite number of solutions, it's still consistent because there's at least one solution, right? If there's no solution, look at the second point. It says the bottom one says if a system has no solution, it's said to be inconsistent. So consistent means there's at least one solution. If there's no solution, meaning they're parallel, that's called inconsistent. I bring all this, you have to know all this stuff just so that we can be talking about the same stuff. When you see a question in a book, you go, oh, I understand what they're saying. So you've got to know the terminology, the math terminology, the jargon. If a consistent system has exactly one solution, it is said to be independent. If it has an infinite number of solutions, it's dependent. This means that there are an unlimited number of solutions that satisfy both equations. Anyway, look at the chart. This is the part that is important. The chart. If there is, I'll draw the chart. Even though it's in the book, I'll draw it anyway for you because I'm so kind. Okay. If there is exactly one solution, then it is considered to be consistent. Why is it consistent? Because it has at least one solution, right? If there's one solution, then it's consistent. If there is, and it's called independent. Why is it independent? Because it's saying independent, E-N-T. Consistent and independent. It's that because there's exactly one solution. You just got to memorize this, right? One solution, consistent, independent. If there is an infinite number of solutions, which means that they are the exact same line, right? That means it's consistent. Why is it still consistent? Because there's at least one solution, consistent, and this now becomes dependent. Okay? And then if there is no solution, if there's no solution, that means the lines were parallel, right? The lines are parallel, no solution. That means they're called inconsistent. Now, the graphs then would look like this, right? Here's our guy here, right? If graphs, they go like this, and then they cross. Oh, you go, oh, wow, there's the point, right? That's one solution. Agreed? Here, an infinite would mean that they are the exact same line, right? One big exact same line. And then the other one would be if they're like this and they go whack, whack, parallel. Make sense? You see, you understand? This is not something you're going to need to learn as much as it is you're going to have to memorize, right? You just got to memorize this. You got to know the terms. Okay, let's do a few of these babies. Let's have you guys do a couple of these. Let me find one here. Okay, hold on. Before we do any of this, let's just look at this. I'm going to give you this. Y equals 2x plus 3 and y equals negative x minus 1. I want you to look at this right here and tell me, without no graphing, tell me, are these things consistent, inconsistent, dependent, or independent? I want to know what these are without graphing. You should be able to look at this and tell me whether or not these are consistent, inconsistent, dependent, or independent. Well, what do we have to figure out? The only thing we have to figure out is how many solutions are there. That's all we have to figure out. If there's exactly one solution, we know that it is consistent and independent. If they are the exact same line, we know that it's consistent and dependent. If they're parallel, meaning that there's no solutions, then it means they're inconsistent. Do you understand what I'm saying? So then how many solutions are there to this? There's exactly one. How do you know? Different slopes, right there. If they have different slopes, that tells you everything. Different slopes. The only thing is if they have the exact same slope, then you're going to look and go, ooh, are they the exact same line? If they're the exact same line, then you know that they are the exact same line. And that means that they are consistent and dependent. Does that make sense? Okay. So then this one is exactly one solution. So you would say that it is consistent and independent. Just got to memorize it, right? Okay. What about this one? What if I gave you this? Y equals negative 2x minus 3 and 6x plus 3y, plus 3y equals negative 9. Try that for me, please. I just want you to tell me, without graphing, whether it's consistent, inconsistent, dependent, or independent right now. Okay, hold on. What are these two things called again? System of equations, right. First thing I do is solve for y. In other words, get them into slope-intercept form so that I can be looking at this and know what I'm looking at. Because this right here doesn't mean anything to me. I know it's a line because it's written in standard form, but I can't tell what the slope is without actually solving for y. Make sense? Okay. Because really, aren't we just looking for the slope? If we look for the slope, we can figure everything else out. Get this thing solved for y, look at the slope, and then we can decide what's going on. So on this one already is in slope-intercept form, yes? Don't need to do anything. Here with this one. Minus 6x, they're gone. 3y equals negative 6x minus 9. Agreed? Okay, divide by 3, y equals. Okay, what does this guy turn out to be? Negative 2x and then minus 3. What do you see about the two lines? They're the exact same line. You see they're the exact same line? If you just looked at this originally, you wouldn't think that, would you? They don't look like they're the same line. Anyway, so then you would say how many solutions are here? Infinite number of solutions. What would you call that then? Consistent and dependent. Right? You're just going to have to memorize that. Consistent and dependent. Does that make sense? Okay. Let's try another one. This time I want you to graph this, okay? I want you to graph this one using your graph paper and your straight edge. I want this y equals negative 3x plus 10 and y equals x minus 2. All right, so here's the deal. What do we do here? If I ask you to graph this thing, give me the solution of this. What do? You just graph it. All right, let's do this. We'll try and be as exact as possible here. We'll see. All right, and then there's, that was not even close. Okay. All right, the first one is, it gets put at, we'll do blue here. Crosses at 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, crosses up here. Kind of tall. I better go fix that. Okay, crosses there. And the slope is a negative 3, so I went over negative 3. That's like right here. Right here. Okay, let's see if I can get this thing to do what I want it to do. Is that true? Does that look good? 10, negative 3. Is that right? 1, 2, 3, 4, 5, 6. Yes. And then the next one, it crosses at, we'll do this one in red. Crosses at negative 2. Crosses at negative 2. And it goes up 1. So up 1 over 1, up 1 over 1. We'll draw it like this. There. And you can see in green, did I already do green? Purple. In purple that they cross right here. Right? See, somebody did something wrong, right? Yeah, yours, yeah. Yeah, well, that's horrible. This is 3, 1. Does that make sense? Make sense? How many of you got that 3, 1 based on your graph? See, it's important, right? So all of a sudden, it's important. I don't really care. Oh wow, I care about that. No, I don't. Okay, try another one. Try another one. Let's do another system here. Okay, so you're graphing these babies. 2x minus y equals negative 1, and 4x minus 2y equals 6. Okay, I want you to graph that. So listen, when I tell you that I want you to graph it, then you graph it. So I want you to graph it and then give me the solution. Does that make sense? So I'm going to put that down here so we're clear on the instructions. I want you to graph it. That's the first thing. And then number 2 is give me the solution. Okay, so before we do anything, what do we have to do? Solve each one for y, right? I have to turn them into lines. I gotta know what I'm looking at here, right? And you should have been able to, once you got that down, you should have been able to look and go, okay, wait, I know the answer. Even though I'm making you graph it, you should have known how many solutions there were just by looking at it. But we'll solve them each. So the first one goes, okay, it's 2, oops. The first one goes 2x minus y equals negative 1. So we go minus 2x, negative y equals negative 2x minus 1. I have a negative y. What do I do? Flip everything, right? I'm going to multiply everything by negative 1. So it's y equals 2x plus 1. There's the first one. The next one goes 4x minus 2y equals 6, minus 4x, negative 2y equals negative 4x plus 6. Divide by negative 2, divide by negative 2, y equals, and now I go, okay, this becomes 2x and then minus 3. Do you agree? Okay, so now that I have them, I have y equals 2x plus 1 and y equals 2x minus 3. I look at these guys, and I mean, yes, I could graph them, but I can look at this and go, wait a second, I notice they have the same slope, and they cross y at different places, which means these two babies are parallel, right? And when we graph it, we're going to see that. But knowing they're parallel, I already know the answer to this up here. The solution is no, right? No solution. Agreed? We know that, but now let's graph it anyway, because it says to. If I give you a place to graph it, you got to graph it. 2x plus 1. So cross here at 1. It has a 2 slope. There's one of the lines. And the other one crosses at negative 3. Also has a 2 slope. And my 2 lines, not drawn very well, but you get the point, is parallel. Makes sense? That's what your answer should look like, exactly like this. How many of you got this? Does it make sense? Does it make sense? Okay. There's really nothing else to do in this assignment. Well, a lot of the times, look on page 336, the top up there. It says use the graph at the right to determine whether each system is consistent or inconsistent and if it is independent or dependent. So here's the deal. You can look over there at those graphs, that's fine, or you can look at that. They've already gotten all these things written in slope-intercept form for you, or almost do, right? You might need to change some of them to slope-intercept form, that's true. Once you get 1, 2, 3 are done for you, but 4, 5, and 6 aren't. Anyway, they just want to know if that system there is inconsistent, consistent, dependent, or independent, right? Got to know. If you haven't memorized it yet, where should you consult? Page 333, right? Should you write that down somewhere? Page 333 chart, just so you can remember that's where you look to know if it's consistent or inconsistent, dependent or independent. Look at number 2. Sorry, not number 2. Example 2, which is 7 and 8. What's the instruction say? It just says graph each system, right? So graph each system and determine the number of solutions that it has. If it has one solution, name the solution. So if it has an infinite number of solutions, you'd put it in, you got to graph it. It says to graph it. Then you put down infinite number of solutions, or no solution, or you put down the solution if there is one. If there's one solution, what's the answer going to look like? If there's one solution, what's the answer going to look like? It's going to be, but what's it going to look like in your answer column? It's going to look like what? An ordered pair, right? It's going to be an ordered pair. It's going to be, 4, 2, or something. If there's one solution, it's going to look like this. Okay? That's it. That's it. There it is. Okay? A lot of the stuff you do, it will say, tell me how many solutions there are. If there's one, name it. Okay. Your homework. Really quick, before I do that, before I let you go, I am going to show you, I'm going to just give you the absolute beginning to tomorrow's lesson so that you can understand where we're going, okay? So before I give you that, because I don't want you to be, all excited about getting to start your homework, because then you wouldn't pay attention. 6.2 is called substitution. So hold on. The first way we learned how to find a solution to a system of equations is by graphing. We just did that, right? That's what you're going to do for your homework tonight, is graphing. Tomorrow's lesson is going to be based on substitution. Here's the example. X plus 2y equals 6 and 3x minus 4y equals 28. Here's how we do it. So pay attention. Here's how this works. First of all, could you graph this and find me the answer? Could you graph it and find me the answer? The answer is always, yeah, you can always do it, right? There's a system and there's 2 lines. You could graph it to find me the solution. Does anybody want to graph this when we're dealing with numbers like 28? No. Nobody wants to graph that, right? Not going to be exciting. So there's other ways of doing this. And there's a few questions on your test where I go, find me the answer. Meaning you get to use whatever method you want. Find me the solution. Use whatever method you want. In fact, I should be able to do that for the whole test, because sometimes the easiest one is graphing. Sometimes the easiest one is substitution, which is what we're going to do right now. Here's the deal. Remember, this is a line, and this is a line. What we want is we want where they cross. Where they cross is where x and y are both the same, right? Where the answer is true for both. So, what we're going to do is this. We're going to look for this and go, okay, that x is alone. He's the easiest one to solve for. I could substitute for anything I wanted to, but I'm going to choose the x because he's the simplest one. Solve this one for x. How would I solve this for x? What would I have to do? Minus 2y. So I'm going to go minus 2y, minus 2y. Okay, it's going to be x equals negative 2y plus 6. Do you agree with that? Okay, that this right here and this right here are the same. I've just shifted 6y from one side to the other. Now that I have what x is equal to, I'm going to go plug that in down here in this x. I'm going to go plug this baby, what x is equal to, into that x. So what that means is this. I'm going to rewrite this with, instead of it being an x here, I'm going to put what? Negative 2y plus 6. Watch. So I'm going to go 3 times negative 2y plus 6 equals, minus 4y equals 28. Notice what's the difference between this and this now is that instead of x, I have what x is equal to in its place. Do you agree? That's all I've done. Now, I'm going to, rainbow, rainbow, negative 6y plus 18 minus 4y equals 28. What can I do with this now? Negative 6y and negative 4y is negative 10y plus 18 equals 28. Minus 18 minus 18, negative 10y equals equals a positive 10. Divide by negative 10, divide by negative 10. Y equals negative 1. Guess what? Remember, these two things are two lines, and unless they're parallel, then you know that there's one solution, right? Well, guess what? We know what y is. Y is negative 1. What do you think I'd do with that negative 1? Go plug it into the original question, the original one. Go plug it into this up here. I'm going to plug it into this. I'm going to plug that negative 1. Y equals negative 1. We already have that. I'm going to put that down here. Y equals negative 1. I'm going to plug negative 1 into the original up here. So x plus 2 times negative 1 equals 6. X minus 2 equals 6. Plus 2 plus 2. X equals 8. Guess what? X equals 8. 8, negative 1. If you want to know whether or not this is right, you go plug in x for 8 and negative 1 for y into both these babies, and it should be true for both, right? It should be true for both. If it's true for both, you got it right. Question?
So, whichever is the smaller one?
No, whichever one is the most open. Like, for example, if I gave you this, if I said 3x plus y equals negative 17 and 4x minus 2y equals 10, which one of these variables am I going to solve for here? I'm going to solve for that y because it's the simplest one. I could solve for this x, but all of a sudden I've got a big mess, right? If I was to solve for this y right here, I'm going to subtract 3x from both sides. It's going to be y equals negative 3x minus 17. Make sense? One simple move, and x is alone. If I was going to, I could absolutely solve for this x right here, but then all of a sudden to solve for that x, I'm going to go, okay, 3x plus y equals negative 17. Minus y, I now have 3x equals negative y minus 17, and I'm going to divide both sides by 3. X equals negative y minus 17 over 3. And now I'm going to substitute that ugly thing into where x is here. And ew, I don't want to substitute that big mess, right? I only would use substitution if there's a variable that's alone. That's the only time you would use substitution. Make sense? And you choose the one. What if there was this? What if it said x plus y equals 8 and 2x minus y equals negative 10? What would you solve for? Either one, x or y. It doesn't matter at that point. You would pick one of them. Does that make sense? You'd pick one. Okay. Anyway, that's how you do tomorrow's lesson. Let me give you, we'll talk about that more tomorrow. Your homework tonight is, remember to be very meticulous. I'm kind of crazy about that when it comes to this. All right, I have page 345, 8 through 22. No. I have 345. No. Page 3. What is this? Page 3. Not 45. Page 3. 336. Page 336. 1 through. No. I have 10 through 24. 10 through 24 even. Does that make sense? 10 through 24 even. Yes, super simple. Okay?